Good morning to everyone. So last class we can discuss about the solid mechanics. In this solid mechanics we can discuss about the static, dynamic, linear and non-linear. So everything will be finally grouped into an geometric classifications of solids. So before going to the finite element procedure, we want to classify the geometry in the different dimensions. So first we are classified into an one-dimensional geometry, two-dimensional and then three-dimensional. How we can able to classify into one-dimensional, two-dimensional and three-dimensional elements. If we are going to considering about the one-dimensional elements, but really the object will be in a three-dimensional conditions. But comparing to the one-dimensional, the other two dimensions will be very minimum. Such kind of cases we can consider as an 1D problem. For example, the beam will be considered as an 1D. In this beam, the length will be very high. For example, of you take it as an bridges, flyover bridges. In this, the length of the flyover will be very long. It will be in kilometer conditions. Compared to the length, the breadth and thickness of the bridges will be very minimum. It will be in meter or less than the meter for breadth and thickness. So such kind of problems we can classify into an 1D. In this, the length of the objects will be take it as a major parameter, and then the breadth and thickness will be considered as a secondary parameter. We solved the problem is based on the one dimensional, but final output will be in a 3D objects. So real-time components, we can get this a final solution for a real-time components. So that will be considered in a 1D problem. If we go for a 2D problem, that's also the having a three-dimensional objects. Comparing to the three dimensional, the one dimensions will be very minimum. If we take it as a thin plate, in this they having a area like a breadth into height, and then they having a thickness also. Comparing to breadth and height, the thickness will be very minimum. Such kind of cases, we can eliminate the thickness for a major parameter. Only we consider for a breadth and thickness, breadth and height. That will be a major parameter. The secondary parameter we will give it as a thickness. Finally, we solve the problems in a 2D manner and get the results from the 3D output. So such kind of cases we can consider as 2D elements. We go for an 3D. All three dimensions will be equal or more or less equal. Such kind of objects we are considered as 3D objects. In this, we are considering a three dimensions will be in a major conditions. We won't give any secondary conditions, secondary dimensions values. All the three dimensions will be considered as primary conditions, and we are applying a boundary conditions for that objects. The output also will be taken for a 3D objects. For 3D conditions, the input and output will be in a same 3D objects. For example, cube, prism, such kind of objects, directly we can consider about the 3D objects. So based on the geometry, we have classified into a 1D, 2D, 3D. This will be a geometrical structure. Next video we can going to see about the what are the different types of 1D, 2D, 3D elements are available. Okay, thank you for